Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, in this lecture, we are talking about sampling techniques. So, this is a part of a research methodology topic, right? We are discussing sampling techniques. So, we know that sampling is important in doing research because if you have a large population, right? So, you are unable to capture uh, all the person in the population. So you need to do a sampling, right? So in order to do a sampling, we need to know what type of sampling techniques are suitable for this to do a sampling, right? So now look at the definition of sampling. So the sampling is a process of selecting a sufficient number of elements. We need to taking a sufficient number of elements from the population so that the result from the analysis are the sample are generalizable to the population. So we cannot do simply set. So we want to take 100 element, or we want to take a 30 element. So we need to calculate the sample size based on a certain criteria. There are many methods of determining the sample size, such as you can use a sample size based on effect size, based on the proportion, based on the mean, and based on the latest one is based on the type of statistical method that you're going to employ. It based on the variables, or how many variables do you have, how many objective you have, right? So it's actually a big topic to discuss about the sampling size, right? So we are talking now, for this lecture, we are looking into a sampling techniques. So sampling means that the process of selecting a sufficient number of elements from a population so that the result from the analysis sample are generalizable to the population. Right. So the term that you need to understand in sampling techniques topic, first is the population. So the population is referred to the entire group of people, event, or thing of interest that the researcher wish to investigate. So for example, let's say you want to measure knowledge, attitude, and practice on dengue fever at Perak Tengah district. So the population will be all the residents in Perak Tengah district. So the element means that the single member of the population, every member in the population is called as element. So then a sample, it means that a subset of the population, right? It comprises some members selected from the population. So sampling unit, this is another term. Sampling unit is the element or set of elements that available from a selection in some stage of the sampling process. So when you're selecting the element from the population, it is called as a sampling unit. You have a population. In the population, you have a lot of members. So the member in the population is called as an element, right? So you want to do a sampling. So you select some member in the population to be in your sample, right? So the member that you already selected is called a sampling unit. A subject means a single member in the sample. It's just an element in a single member of the population. It's the same thing. It's just a term that you need to digest before we move on to the next process. So the relevant terms, the characteristic of a population such as mu, this is a population mean, this is a sigma, which is a population variance, are referred to the parameter. Means that we are taking mean and the variance from the population, right? So when you do a sampling, right, the central tendencies and the dispersion or other statistics in a sample of interest to the research are treated as approximation to the central tendencies, dispersion, and other parameter of the population. Right. So this is a sample statistics, and this is a sample parameter. Right. Parameter we measure from the population. Statistic we measure statistical measure from a sample. right? So advantage of sampling, of course, when we have a population, a very large population, when we do a sampling, we cut down our cost of doing capture all the member in the population. It will less the cost, less error due to the less fatigue, less time, destruction of element avoided. So this is the advantage of sampling. So before we move to the sampling techniques, right, we need to understand the sampling process. So the major step in sampling first start with the defining the population. So we need to understand what is our population. We need to determine the sampling frame if you have. So if you are doing a small study, maybe you can get a sampling frame. If you do a population, let's say a resident study at resident area, district area, so maybe getting the sampling frame is not possible at all. So once you already have the sampling frame, then you need to determine the sampling design. The sampling design, it can be either a probabilistic sampling techniques or non-probabilistic sampling technique. This is what we're going to discuss now. Right. Determine the appropriate sample size. Once you already determine the sampling design, well, you know already what type of sampling technique that you want to employ. So you need to determine how much you want to take from the population, how many elements, how many members that you want to take from the population. So this is the kind of the role of sample size calculation. So once you already determine this the first four step, so then you're going to execute the sampling process. How to execute the sampling process? Here come the part that you already discussed in previous lecture, which is a data collection method. You have a survey research, you got a questionnaire, face-to-face interviews, you got observation or experiment, right? Now, example number 1. So a satisfaction survey was conducted for a computer retailer in New Zealand. The objective of this survey to improve internal operation and thus to retain more customer. So the survey was transactional in nature. Survey satisfaction and several related variables are measured following the service encounter, which is, for example, a visit to a retailer. So now, here's the customer feedback was obtained while the service experience was still fresh. To obtain the representative sample of customer of the computer retailer, so this is what we call as customer of computer retailer is our target population. Every 10 person leaving out the 10 randomly selected store in randomly selected cities in randomly selected region was approached during 1 week period. So this is the sampling technique that we apply. So in this case, we know that maybe you quite not know about this, but we're going to discuss later and in this lecture. This is a systematic sampling techniques. Trained interviewer was sent out with standardized questionnaire approach 732 customers leaving the store. So this is 732 is our sample size, right? So this is another example, right? So I'm not going to read this one. You can pause the video and read this one for a while. And then in this example, I already showing you what is a sampling frame, right? This is a sampling frame, right? And then the sample size. This is a different example, right? So you can have a look and try to differentiate what is a sampling frame, what is a target population, and what is a sample size, and what is a sampling technique they use, which is a judgment sampling methodology, right? So sampling techniques, there are two types of sampling techniques. First is a probabilistic or probability versus non-probability or non-probabilistic sampling techniques. In the probability sampling techniques, element in the population have a known and non-zero chance of being chosen. Means that everybody every element in the population, every member in the population have equal chance to be chosen. So this is a probabilistic sampling techniques. Right, now look at this chart. So in sampling techniques, we have two parts of sampling techniques. First is probability sampling techniques. Another one is non-probability sampling techniques. On a probability sampling technique that we're going to discuss in this lecture, which is a simple random sampling, systematic sampling, stratified sampling, and cluster sampling. For non-probabilistic sampling techniques, we have convenience, judgment, and quota. Right. So let's look at the first sampling techniques under probabilistic sampling techniques. Well, in a simple random sampling, a procedure means the first procedure is each element has known an equal chance of being selected. So means that every member in the population has equal chance of being selected. The characteristic of a simple random sampling is highly generalized, easy to understood, reliable population frame necessary. So we need to have a full set of sampling frame. So this is an example of sample random sampling. This sampling design is best when the generalizability of finding the whole population is the main objective of the study. Let's look at the example. The human resource director of a company with 22 people on its payroll has been asked for a vice president to consider formulating and implementable flex time policy. The director feels that such a policy is not necessary since everyone seems happy with 9 to 5 hours working hours. Right. So no one has complained. Formulating such a policy now, in opinion of a director, runs a risk of creating domestic problem for the staff and scheduling problem for the company. She wants, however, to resort the simple random sampling procedure to do an initial survey and with the result convince the VP Vice President that there is no need for flex time and urge him to drop the matter. Since sample random sampling offers greatest generalizability of the result to the entire population and the Vice President need to be convinced, it is important to resort to these sampling techniques. So means that you're going to use a simple random sampling, right, to get the non-biased response from the people, right? So you can read this one. This is an example from a for Umar Sekaran book, which is a research method for business. So I just want to go through. So in the next sampling technique, this is a systematic sampling techniques. In the systematic sampling techniques, a procedure of a systematic sampling technique is each n element starting from with random choice with element within 1 and n. So it means that we're going to select the element from a population based on the k element. The k value means that the k value is calculated based on the number of population divided by number of sample size. So you will get the k value. So the first element that we're going to select, or the first sampling unit that we're going to select from a population, is a random sampling techniques. And then the subsequent number of a sampling unit that you're going to select is based on the k value, right? So it's actually not a fully randomized sampling techniques. So the characteristic is IDEM, simple random sampling, easier than simple random sampling. We no need to have a complete sampling frame. Systematics bias when elements are not randomly listed. So this is the characteristic. So if the sampling frame is large, a listing of element is conveniently available in one place, such as a telephone directory, company payroll, chamber of commerce listing, and so on. So then a systematic sampling procedure will offer the advantage of ease and quickness in developing the sample. So when you have a large population, right, so maybe you cannot have a time to track down each of the element, so maybe you can employ a systematic sampling techniques, right? So this is the example. You can read, you can pause the video and read the example. If you can see, the administrator can assess authenticism for the new scheme by using systematic sampling. The company record will provide a sampling frame, and every N employee can be sampled. So N employee is the same value, which is a K value. So a certified plan is not called for here, since the policy is for entire company, right? So another sampling method lies under probabilistic sampling techniques is a stratified sampling techniques, right? So the procedure is we divide the population in strata, which is in group, right? We include all strata, random selection of element from strata. For each group, we do a simple random sampling by proportionate or disproportionate. Right? The characteristic intra-strata heterogeneity means maybe the each group have heterogeneity, means it's not same characteristic. Intrastratum have a homogeneity, means each group should in their group, in each stratum, it has a same characteristic, but between each group they have no and they have not same characteristic. So let's say, let me rephrase back my word. So we divide the population into several groups. Let's say we divide the population into 4 groups, right? Into a strata. This group we call a strata. So between each group, there might be the characteristic of group A and group B might be not same. So this is the condition of heterogeneity. So in group A, the element in group A should have the same characteristic. So this is an intrastratum homogeneity, right? So the sampling design, this sampling design, which is the most efficient and it is good choice when differentiated information is needed regarding various strata within the population, which are known to differ in the parameter, right? So this is a example. This is a very long example. Same as I said before, this example I taken from a Umar Sekaran book. You can pause the video and read for a while, or you can go straight away to the book and read the example, right? So another type of a certified sampling technique, which is a proportionate and disproportionate sampling techniques, right? Number of subject in total sample is allocated among the strata disproportional to relative number of element in each stratum in the population, right? Disproportionate case means that strata exhibiting more variability are sampled more than proportional to their relative size. Require more knowledge of the population, not just relative size of strata. Means that maybe you are doing you grouping a population into several group, and this group have no no equal proportionality when you selecting the sample. It depends on the sample size. So this is an example of proportionate and disproportionate. If you can see, the proportionate means that we're selecting 20% of the element. So from here, we're selecting 70%. But for disproportionate, we're still selecting the total of 142 of the sample, right? But for proportionate, we are taking the sample from each group, 20% from the population. But for this proportionate, we are not taking all same percentage, right? Let's say this proportionate from top management, we take 7 out of 10. This is half of a 30. This is 20 out of 50 instead of taking 10, or this is 20% of the total population. But this one we take more than 20%. By the end, we got the same sample size. So this is a difference between proportionate and disproportionate stratified sampling techniques. And the last sampling technique that we're going to discuss under probabilistic sampling technique is a cluster sampling techniques. So cluster sampling techniques is also same procedure with the certified sampling techniques, but it's only applied for a large population, right? So the procedure is we divide the population into cluster, means that we divide into groups, and we are randomly select the cluster and include all elements from the cluster. Compared to certified sampling techniques, we divide the population into groups, then we select a sample from each group, right? But for a cluster sampling techniques, we divide the population into groups, which is known as cluster, and we choose we select one or two cluster, for example, and then for each cluster, we select all element in that cluster. We are using what we call as census. We select all. So the cluster is best applied when you have a very large population. The characteristic of a cluster sampling technique is intercluster has a homogeneity characteristic. Intra-cluster have a heterogeneity of the characteristic. It is easy and cost efficient and very simple method to deploy, right? Low correspondence with reality. So this is the characteristic. So this sampling design is useful when heterogeneous group is to be studied at one time, right? So this is the example of a cluster sampling techniques, right? So you can read this one. Same I said before. This is the example taken from Umar Sekaran book, Research Method for Business. Right? You can go straight to the book and read the example. Right. Another example sampling techniques that we're going to discuss now is area sampling. Area sampling is consists of geographical area such as counties, city blocks, boundary within locality. It's less expensive, independent of sampling frame, right? So area sampling is best suited with the goal of research is confined to a particular local area, right? So for example, a telephone company wants to install a public telephone outlet in the locality when crime is most rampant, so that victim can has access to the telephone. Study the crime statistic and interviewing the resident in a particular area will help to choose the right location for installation of the telephone. Right. Another type of sampling techniques, we have a double sampling. So double sampling means that we can employ two sampling method into one sampling techniques. So this is what we call as a double sampling. The same sample or subset of the sample is studied twice. This design provides added information at minimal additional expenditure, right? For example, let's say we look at this one. In the previous exit interview example, some individuals, right, subset of original cluster sample might have indicated that they were resigning because the philosophical different with the company policies. So the researcher might want to do an in-depth interview with this individual to obtain further information regarding the nature of the policy dislike. the actual philosophical difference and why this particular issue were central to the individual's value system, such as additional detailed information from the target group through the double sampling design could help the company to look for ways to retain employee in the future. So now let's look at the next sampling method. Right, for convenience sampling techniques is a part of a non-probabilistic sampling techniques. So this is the most accessible member are chosen, right? Often used during exploratory, right? So because this sampling techniques is easy to employ, we can get element of the population easily, the best way to get basic information and quickly and efficiently. But remember, when you do probabilistic sampling, non-probabilistic sampling techniques, well, sometimes we are not doing a complete randomization. We are not employing a randomization techniques. So means that some of the sample or element that we select from the population might be a bias, might not represent the whole population. So convenience sampling technique, this is a non-probabilistic sampling design, which is not generalizable at all. It is used at a time to obtain some quick information to get feel of the phenomenon or variable of interest, right? Another one is we have a purposive sampling. So purposive sampling is another sampling techniques. It's totally different from a convenience sampling technique, but the main thing is a convenience sampling techniques. So other sampling techniques are employing or adapting the convenience sampling techniques into their sampling techniques. For example, purposive sampling techniques. Instead of obtaining the information from those who are most readily or conveniently available, it might sometimes become necessary to obtain information from a specific target group. So the sampling here is confined to specific type of people who can provide the desired information, either because they are the only one who have it or they conform to some criteria set by researcher. So this type of sampling technique is called a purposive sampling techniques. The two major types of purposive sampling technique is a judgmental sampling techniques and quarter sampling techniques. Right, we will explain about that. So judgment sampling techniques is the elements are selected based on the basis of their expertise in the subject investigated. So a judgment sampling technique is used where the collection of specialized, not informed input on the topic area research is vital. And the use of any other sampling design would not offer opportunities to obtain the specialized information. Right. Let's look at an example. A pharmaceutical company wants to trace the effect of new drug on the patient with specific health problem, such as muscular dystrophy, and so on. Right. It then contacts such individual and with a group of voluntary consenting patient testing the drug. This is a judgment sample because data are collected from appropriate special group. Right. Another type of purposive sampling technique is a quarter sampling techniques. The quarter sampling technique is a subject are conveniently chosen from a target population, right, target group, according to the some predetermined number of quota, right. So let's say we want to get female respondent 500, male respondent 200, for example. So this is based on quota. Similar to proportionate stratified sampling, but is not generalizable because this is a non-probabilistic sampling techniques. There are no randomization effect apply in the quarter sampling techniques. So these sampling techniques or sampling design allow for inclusion of all group in the research system research. Thus, groups who are small in number are not neglected, right? So for overview, so we already discussed probabilistic sampling techniques and non-probabilistic sampling techniques. So simple random sampling, all elements in the population are considered and each element has equal chance of being chosen in the subject. Advantage, high generalizability of the finding, and disadvantage, not as efficient as stratified sampling techniques. Systematic sampling techniques, every n element in the population is chosen starting from the random point in the sampling frame. Easy to use if sampling frame is available, right? But if the sampling frame is not available, we also can conduct the systematic sampling techniques. It does not require full sampling frame. Systematic sampling technique might be a bias sampling technique. So because only the first element selected randomized, others element, subsequent element are based on n element. Right. Certified random sampling is the population is first divided into a meaningful segment. Therefore, subjects are drawn in a proportion into their original number of in the population based on a criteria other than their original population number. Advantage is most efficient among all probability design. All groups are adequately sampled and comparison among groups are possible. The disadvantage is certified must be meaningful, more time consuming than simple random sampling or systematic sampling. Sampling frame for each stratum are essential, means that we need to have a complete sampling frame to employ certified sampling techniques. For cluster sampling techniques, a group that have a heterogeneous member are first identified. Then some are chosen at random. All the member in each of the random group are being studied. Means that we're going to include all member in each cluster. The advantage is in a geographic cluster, cost of data collection are low. Right, and disadvantage is less reliable and efficient among all probability sampling design, since subset of cluster are more homogeneous than heterogeneous. So this is the disadvantage. Now look at area sampling. Cluster sampling within a particular area or locality. Right. Advantage is cost effective, useful for decision relating to a particular location. Take time to collect data from area. So this is the disadvantage. Double sampling, the same sample or subset are sampled in subset or the sample is studied twice. Offer more detailed information in the topics of the study, right? And disadvantage is originally biased. If any, will be carried over. Right. Individual may not be happy responding second time. So when you are asking the same question or maybe a different question, set of question to the same respondent, maybe the respondent will not be happy. For non-probability sampling techniques, we are discussing three of the sampling techniques, which is the first one is convenient sampling techniques. The most easily accessible member are chosen as subject. Quick, convenient, less expensive. This is the advantage of convenient sampling techniques. But disadvantage is not generalizable at all. Right? Judgment sampling techniques, subject selected on the basis of their expertise in the subject investigated. Sometimes the only meaningful way to investigate. And the problem with the judgment sampling techniques is generalizability is questionable, not generalizable to the entire population. So this is the main disadvantage. The last one is quarter sampling. Subjects are conveniently chosen from a target group according to some predetermined number of quota. It's very useful when the minority participant in the study is critical. But the problem is not easy to generalizable to the population. So this is the advantage and disadvantage of each sampling technique that we already discussed. So now, choice point in sampling design. So if your sample is representative of the sample critical in your study, if yes, then you need to use a probabilistic sampling techniques. If no, then you can choose probabilistic sampling techniques or non-probabilistic sampling techniques. Either one, right? So if you are using probability sampling techniques, if the purpose of study mainly for generalizability, if you are concerned about generalizability, then you choose either simple random sampling techniques, systematic sampling techniques, or cluster. If your objective is to assessing differential parameter in subgroup population, then you need to ask either the group number are equal or not equal. If equal, then use proportionate stratified sampling techniques. If not equal, disproportionate stratified sampling techniques. If your purpose of the study or objective of the study is trying to collect information in the localized area, so you can use area sampling techniques. If you are gathering more information about a subset in the sample, use double sampling techniques. Right. So this is when you have you are choosing probability sampling techniques. If you are choosing non-probability sampling techniques, look at your purpose or objective. If your objective is to obtain quick and unreliable information, even if it's unreliable information, then you can straight away use convenience sampling techniques. If your objective is to obtain information relevant to and available only with a certain group, then you can choose either one. If you are looking into information that with only expert can provide, choose judgment sampling techniques. If you need a response or special interest minority group, then you can use a quarter sampling techniques. So this is the flow of how we're going to choose your sampling technique in your research, right? So now, let's look at the most important part after you determine your sampling techniques. After you determine the sampling technique in your research process, remember in the first lecture I stated, first in the research process, in sampling process, first thing we need to identify what is our population. Second is we need to determine our sampling frame. The third is we design our sampling techniques. The number 4, we need to consider what is our sample size. And the last is we do a data collection. Right. Sample size, it depends on pre-assumed parameter value, confidence interval or confidence level, degree of variability based on the prior study or pilot study. Power of the test. This is another dependency of sample size. Power of the test means a type 2 error, right? The 1 minus type 2 error. We got the power of the test, or power of the test, which is beta, right? The ability to detect what it is looking for. 1 minus beta means beta is a type 2 error. 1 minus beta is the opposite of type 2 error, which is our power of the test. So we need to have at least 80% of the power. Right. So this is an example of a sample size determination for a single mean. Right. See, this is a Z value. Right. 1 minus alpha divided by 2. Alpha is getting from a type 1 error. Right. So multiply with the effect size. This is the standard deviation, population standard deviation divided by the difference or effect size of the population. So this is for a single mean. And this is a test of proportion. So it's the same procedure. We just replace standard deviation to the proportion, right? Proportion and multiply with complement of the proportion. So computation of sample size based on proportion. A pilot study with a small sample size shows that only 40% of housing projects were complete on time. So this is the case. Determine an optimal sample size to estimate the proportion of delayed project within 5% of the true proportion with a 5% level of desired accuracy, 95% confidence. So the Z value is Z value based on 2 standard deviation, right? 1.96. So the proportion is 0.4, means that 0.4 is our based on the literature, right? Based on the literature, 40% of housing projects are delayed complete on time, right? So this is our proportion, complete on time, and our complement of the proportion, which is Q1 minus P, is delayed. Delayed means 0.6, 60% of the time. And the estimate proportion or the effect size, you can find this from the expert opinion or from the literature, right? Literature review. So we can find an effect size, which is 5% of the true population of 5% level of desired accuracy. So D is equal to 0.05. So by plug in this value into this formula, you will get 384. So 384 is the minimum sample size required. Substitute above figure in the formula, right? By substituting this value into the formula. Right, computation of optimal sample size based on mean. So look at this one. A study is interested to determine the actual cost of building a low-cost house in Klang Valley from a similar previous study conducted in Ipoh. It is estimated that average cost of building such a house is 12,500 with a standard deviation of 105,000. So, right. So, determine an optimal. This is, I think, this is. I'm not sure about the value, but we just look at it as an example, right? So determine an optimal sample size to estimate the mean cost of such house is if it desired that the mean estimate is within 100 ringgit with a confidence level of 95%. So confidence level with 95% is determined by type 1 error. So Z value is, let's say we take a 2 standard deviation, 1.96. Sample standard deviation is 1,500. And the effect size, the mean estimate is 100. So the sample size, we take this value and plug into the formula, to this formula, you will get 900. 900 is the minimum sample size required, right? So there are another formula. There are a lot of formula of determining a sample size. This is a sample size with 2 means, right? When you have a 2 mean paired, and when you have a 2 mean independent group, right? So you're going to use this one and this one, right? But basically, there are a lot more. About a lot more of formula of calculating the sample size. Most recently, we are looking into calculating sample size based on type of statistical method that you want to use, right? So that one is a most recent one, right? I think that's all. Thank you very much. Assalamu alaikum.